Okay, good evening, everyone. I'd like to welcome you all here this evening on a messy Thursday evening as far as the weather is concerned outside, but we have a very special event this evening. So thank you very much for coming. My name is Greg Natterer. I'm the Dean of the Faculty of Engineering and Applied Science here at Memorial, and it's a pleasure to see you all at our Speaking of Engineering lecture series. I'd like to extend special greetings this evening to our guest speaker, Jennifer Williams, who is the president of Newfoundland Labrador Hydro, Memorial alumnus. Welcome, Jennifer. I'd also like to acknowledge Jeff Emberley, who is CEO and registrar of Paganel to my left here. He will come up a little later to talk about Paganel's sponsorship of this lecture series. This session is co-sponsored by Paganel, Professional Engineers and Geoscientists of Newfoundland and Labrador, which is an organization with the mandate of regulating the engineering and geoscience professions in the public interest of the province. There's approximately 4,000 members, and we're grateful for the support of Paganel of this lecture series. Just a few housekeeping items before we begin. We don't have any anticipated emergencies, but in case there is an alarm, I'd like all of us to exit the building and this room in a calm manner. We could turn to the right as we exit out the main doors, go to the left. The muster station is in the parking lot of business across the street in the event that that happens. Also, the washrooms here on the main floor are just to your left as you exit this room. So this lecture series raises awareness of engineering issues among the general community, students, faculty, and broader interests, again, of the community. We're actually very proud of the work that goes on here in the Faculty of Engineering and Applied Science. So I'd like to just spend a few moments talking about some recent exciting things that have happened. We have a Paradigm Hyperloop student team that has done very well internationally in the competitions, and they've been selected among a very small group of finalists who will be competing in July in California at the 4th International Hyperloop Pod competition. They've actually are in the process of designing the first ever electric propulsion system that accelerates Hyperloop pods to very high speeds, and we're very proud of their success. Our students also competed nationally just recently, about a month ago, at the Canadian Engineering National Competition, and we're very proud of the success that they had. 2 teams placed second in Canada, one in the consulting category, where students developed a very impressive flood plan of a large city in response to climate change, and another team of students that placed second in Canada in the consulting competition. So, in addition to students, we're also very proud of our alumni. Recently, Kate O'Brien, a graduate from electrical engineering in 1996, was appointed as a judge of the Supreme Court of Newfoundland and Labrador. So, many of our engineers go on to technical careers, but we have others also that go on to law, medicine, and other professions. We're very proud of her success. Jim Haynes, also a graduate of electrical engineering in 1977, is now the executive vice president of Nalcor Power Supply. And of course, our speaker this evening, Miss Williams, who is a civil engineering graduate and the first female president of Newfoundland and Labrador Hydro. Tonight's lecture that Jennifer will be giving is about how a hydro plant in the rural Newfoundland has provided reliable electricity for the island for over 50 years. She'll talk about how the Bay d'Espoir plant, located about 170 kilometers from the Trans-Canada Highway in central Newfoundland, has helped to provide electricity on the island for over 5 decades. It uses water, rain, and snow to provide highly reliable electricity to this day. We'll learn about how the plant has managed some major repairs and upgrades in the past few years, and how it will continue to play a major role in the province's electricity supply going forward. She was appointed as president of Hydro in February 2019, and previously she served as vice president production with Hydro since 2016. She was also the general manager of hydro production and the manager of regulatory engineering at Hydro prior to that. And also prior to 2014, going backwards in time, she worked with Newfoundland and Labrador Power and St. John's International Airport Authority. She graduated from Memorial with a civil engineering degree and is a member of Paganel, where she has been an active volunteer, including as a member of the board of directors. In 2016, she received the award of Fellow of Engineers Canada in honor of her exceptional contributions to the engineering profession. So without further delay, please join me this evening in welcoming Miss Williams. Jennifer, over to you.
Okay, I'm going to make sure everyone can hear me with this mic. Everyone can hear me good? Okay. Thank you, everybody, for coming out tonight, and certainly Dr. Nadler for inviting me. It's pretty exciting. As you mentioned, this new job is hot off the press. So I'm still adjusting to the current demands as I'm still juggling some of the duties of the old demands, but I'm really pleased to take the role on, and it's pretty exciting for me. So as you mentioned, we're going to talk about Bay Despair, and how we'll start the evening is I'm going to do, we do safety moments, as I'm sure a lot of organizations do safety moments, but I'm going to choose to do a diversity moment. I think it was about a year or two ago, in place of diversity safety moments, we started doing some diversity moments, I think around International Women's Day. But certainly diversity is not just women, it can be other underrepresented groups. So I'm shamelessly stealing from MUN. Make sure I can get this to work now. And MUN does a land acknowledgement. So I don't know if anybody here who has been in the presence of some other meetings, probably at MUN, that do land acknowledgements. But I'll read this out. I do my best not to do a lot of reading from the screen, but I certainly want to do that in this instance to make sure I get all the information correct. A land acknowledgement is offered to recognize Aboriginal peoples during connection, and Aboriginal peoples' enduring connection, to their traditional territories, to recognize the history of the land that is currently shared by many peoples, and to recognize stewardship as a shared commitment of all those who reside in a territory. The practice of territory acknowledgement is itself a replication of an Aboriginal practice which predates European contact. So this is the land acknowledgement that MUN has, and so they have one for St. John's campus. This is the St. John's campus, and they also have one for Grenfell. And you can just Google it if you want to use it in any of your meetings that you might be participating in if you're thinking about doing a safety moment, or if you want to evolve that into diversity moments. Got some friendly faces here who probably heard this heard this today. Actually, I think I used this diversity moment today. We respectfully acknowledge the territory in which we gather as the ancestral homelands of the Beothuk, and the island of Newfoundland as the ancestral homelands of the Mi'kmaq and Beothuk. We would also like to recognize the Inuit of Nunatsiavut and Nunatuavut, and the Innu of Nitassinan and their ancestors as the original people of Labrador. We strive for respectful relationships with all the peoples of this province as we search for collective healing and true reconciliation, and honor this beautiful land together. I will just kind of really quickly do this so I don't forget to do it at the end. I won't go through my background as Greg has talked about it, but I am going to put in a bit of a plug for Paganel. Greg mentioned that I did spend some time on the board of directors, and before that I did some other volunteer work. But for anybody who's in the room who may not have participated before in Paganel, I don't think I realized at the time how good a professional development it was. I really wanted to sort of get involved and give back. I might have been encouraged by Jeff, actually, because we used to work together, to put my name forward, and I did. But looking back on it, it was probably one of the best experiences at that point in my career from a development perspective, so I highly endorse anybody considering doing something with Paganel. I wanted to get that in, Jeff. You owe me $20. Okay. I'm going to read this one out too. I promise I'm not going to do this all night. But this is just a short excerpt from a paper that was written for the Canadian Electricity Association back in 1972 by Wally Reed and Leo Cole. And it was really a description paper just about the Bay Despair development. And there was one sentence in particular I found very interesting or very impressive. From 1964 to 1970, the island of Newfoundland witnessed a massive transformation in its electric power program. This is the really neat part. What had developed in other provinces over a period of 60 years in electric utility growth had now to be compressed into 6 short years. A very serious shortage of power and a low level of domestic electrification required a giant step approach to the island's next move on electrification. Blessed with a large source of hydropower centrally located, the government of the province gave the green light to the Bay d'Espoir site as the generation source for a whole new trans-island power system. So that's pretty neat. I thought it was just really stood out to me, the pace of growth that would have been going on that would have precipitated the urgency to get this work done. So this is a quick snapshot of hydro system. Certainly there's some other friendly faces here from Newfoundland Power, and it's a companion and a complementary system to hydro system. Hydro is obviously the primary generator and transmitter of electricity in the province, and we sell that power to Newfoundland Power, who in turn sells it to the customers. We generally have, have some other distribution level customers as well, about 38,000. And mostly in rural Newfoundland, we have some sort of interconnected on the island, but certainly all of Labrador is the customers that we serve. And we have some large industrial customers in the province as well. We have 9 hydroelectric plants. The biggest is the Bay d'Espoir plant. It is a little over 600 megawatts. And at that plant, we have 2 powerhouses, 6 units in one at 75 megawatts each, 1 unit by itself in the second powerhouse at 150 megawatts. And the first one obviously went into service in 1967. Oh, I should say this too, just so you can get your questions. This book is a short booklet that Hydro pulled together in honor of the 50-year anniversary of the Bay d'Espoir plant. I gave one away on the way in. But I do have a number of books here. And if there's questions at the end, if anybody's interested and a real electricity nerd, then you can have one of these books. I've got about 10 or so. And if we don't have a ton of questions, I'll look for the friendliest faces, so make sure you're smiling. After Bay d'Espoir, there's some other systems, other plants. Cat Arm is another very large plant. I'm calling it large, considering the units themselves. 127 megawatts. It's got 2 units. It was put in place in 1985. Upper Salmon, 84 megawatts, put in place in 1983. Hines Lake, 75 megawatts, 1980. When you think about that, there was another 300 megawatts that came on the system essentially in 5 years. That is incredible how much construction would have been going on the island at that time. And it was only 13 years after the first unit went in service at Bay d'Espoir. And a few small plants, one 8 megawatts, and then a few other small ones. Obviously, we've got the Holyrood generating station as well, nearing its end of life, 490 megawatts, 4 gas turbines. The most recent one was constructed and put in service in 2015, and it's the one located at Holyrood, 123 megawatts. And you've got one at Stephenville, out at Hardwoods, really paradise, and Happy Valley Goose Bay. And certainly then you've got thousands of kilometers of line, I think over 60 terminal stations and substations, so a very significant electrical infrastructure across the province. So the transformation that we would have seen back in the 60s and then continuing certainly into the 80s, I think, there's another significant transformation, everyone knows it, but I will go ahead and talk really quickly about it, is the new lines in Muskrat Falls that are coming into service. The Labrador Island Link you'll see in the yellow, and we call it the LIL. I don't know if everybody else in the public calls it the LIL, but we certainly do at Hydro. And you've got the Maritime Link that connects, you can see it from right around Granite Canal there, over to Nova Scotia. The Maritime Link went into service in this winter, really, of last year, so it's about a year now that it's been in service. And in the Labrador Island Link, we've got the first bit of Upper Churchill power, which will make some people quite happy to hear, in last summer. And we're continuing to bring energy over that on and off as we commission that line through its various stages. Those new assets are already bringing some reliability benefits, even in their very early life, and certainly on the Maritime Link, we have something now instituted called frequency control. And for the electrical engineers in the room, I'm the civil engineer, so I'm going to try to talk about this. The frequency control, when we were an isolated system, just the island, the frequency would bounce around a little tiny bit in a very short, small band. And when we were interconnected through Nova Scotia and their frequency control is in service, you should have seen literally the excitement of the electrical engineers because the line went like perfectly flat. They were over the moon to see this line that had previously done this go flat because they recognized that as such a monumental change for our system and reliability. And so what it does, is prior to having something like this in service, when we would have a unit trip, which every utility has a units trip, depending on the magnitude of the unit that tripped, we would lose customers while the system stabilized itself. So if you had this much generation for this many customers' needs, you had a unit trip off, the system becomes unstable, so we'd have to drop customers and allow the system to become stable. Add more generation and you can add load. And that would be called under-frequency load shedding because the frequency would drop, it would have to stabilize. With frequency control and service, basically we get emergency response from Nova Scotia, and we're not seeing any under-frequency, so that's pretty exciting. We would have had a number of under-frequencies since that went into service that we're currently not seeing. So that's a significant immediate benefit that we're seeing. So once complete, the Muskrat Falls plant is obviously going to supply power to the island, and we'll be able to shut Holywood down. So it is a time of significant change, and it's going to be, we'll be adjusting to exactly how all these assets operate now over the next couple of years. So while we are adding these new assets as Bay d'Espoir still will remain into the future really great assets. Just because they're 50 years old doesn't mean that they're not still viable. I'm almost 50, I'm still viable. Okay, so I'm going to talk to you a little bit about Bay d'Espoir, a little bit of its history. And I was talking to a gentleman on the way in. He was involved, I guess, was in the area when it wasn't that old. So it's kind of neat that there's some people here who will be able to remember Bay d'Espoir, in its earlier life. So this is where it all began, and I'm pretty sure the man that you see with the shovel is Joey Smallwood. Yep, there you go, Sod Turning by Joey Smallwood in 1965. So as Greg mentioned, it's about the plant for any townies who had never been there before, and I admit I had never been down there before. I started working at Hydro, so I was about 40 years old before I got there. About 170 kilometers off the highway down from Bishop's Falls, Grand Falls, built in the 60s. In addition to the plant itself, there was about 800 kilometers of line that would have been built at the time. So it's pretty incredible, actually, what did get built over just a short period. And for the civil engineers who like this stuff, 7 major dams and 5 major power canals were built as well that had to be constructed in order to provide this, the generation. And the transmission lines that were built certainly ran east-west from Bay d'Espoir, connecting St. John's, Bay d'Espoir, Grand Falls, Corner Brook, and Stephenville. So this really was the beginning of the backbone of the system that we see today. Again, this is just some photos of the plant. And the plant was built in 3 stages over a 12-year period. Stage 1 had the first 4 units, which would then have been 300 megawatts. And it was at that time thought it could project or would project it to provide power until 1978. This was another really interesting stat. At the time of sanction of the development, the load growth was somewhat below the national average, which was still like in the, I think, the low, just under 10%. That was below the national average. It's an incredible time to have been witnessing all this. But at the time the plant was finished, annual load growth was having percent increases of 11, 12. And in 1969, it was 19% load growth. I mean, that is just astounding from a system planning perspective. That would stress me out, I think. Certainly quite an interesting time to try to keep pace with that. And so with the rapid growth of the industry, then 2 more units were added, and then the final unit, Unit 7, the large one, the 150 megawatt unit, was added in 1977. So this is the watershed, and it would involve the utilization of 4 watersheds: Salmon River, Grey River, White Bear River, and Victoria River. And the Bay d'Espoir area features many large lakes throughout the watershed, which led to the easy development of storage. The plant is situated essentially at tidewater and draws water as required through long pond storage, which is on the far end of the screen there, just above the words Northwest Dam. The main powerhouse, so yeah, of the main powerhouse that has the 6 units, there's 3 penstocks that feed the 6 units. And the penstock will bifurcate just before the plant, and then it feeds 2 units each. So if we have to take a single penstock out of service, we're removing 2 units out of service at any time we had to take that out. The surge tanks that were built for on top of only the penstocks for units 1 to 6. When they were built, they were the highest in the world, and they were for surge tanks, and 371 feet high. So again, I know there's certainly some friendly faces here that I know have worked in the utility industry before, but I will just, for those who may not be quite as familiar, Hydroelectricity is the production of electrical power through the use of gravitational force of falling or flowing water through a power generating station. The mechanical energy of the moving water is converted into electricity by spinning large turbines connected to electrical generators. After dropping, this is at Bay d'Espoir, almost 600 feet, the tremendous head of water will turn the turbines, and they will then in turn the generators. For hydro, all of our hydro assets, the hydroelectric assets, they generate on average 4,600 gigawatt hours of energy a year. And that is about, for the hydro-owned assets, about 60% of the energy that the customers need. So for the green energy that we have, that's quite an impressive number. If you add in the exploits facilities in Bishops Falls and Grand Falls, which hydro manages on behalf of government after they expropriated the assets, it pushes it up to closer to 70%. So the area at the time would have benefited significantly from the hydro plant development with a new wharf, a landing strip, an aircraft landing strip. I don't know if anybody knew that, but Bay d'Espoir has a landing strip, and a road linking the area to Bishops Falls. So I don't think the road down to Bay d'Espoir existed prior to the plant. The first stage of the project employed about 1,800 people, with an average of 1,500 during all stages of the project. The total payroll from the beginning to the end of the first stage was in order of $30 million. During the period of construction, over 90% of the labor force, including management and supervision, consisted of Newfoundlanders. Payday. Oh, that's interesting. Did you see that picture? It says payday. It's kind of neat. Gone are those days. Not that long ago. So this was really interesting as well for me, is some of the engineering firsts. And I mentioned earlier, the surge tanks at the time, at 371 feet, were the tallest in the world. Y-shaped towers was also the first time they were used in the world. Now they're commonplace. The 230,000 kV system was highest east of Quebec, and now it's obviously very common. Our newest one that we've constructed is TL267. It went in service from Bay d'Espoir to Western Avalon, which is around Chapel Arm, and it also is 230 kV. The LIL is DC, not AC, and it's 350 kV. There's an 8,300 foot transmission line crossing over Grand Lake, which is between Buckins and Massey Drive, Corner Brook. And at the time, it was the longest span of that transmission voltage in Canada. And there's some long crossings similar to that now exist. A man-made lake was created, the large man-made lake, third largest lake on the island, still obviously one of the biggest. And prior to Bay d'Espoir, the largest plant would have been Deer Lake, which powered Corner Brook Pulp and Paper. And it had about half of the first stage of Bay d'Espoir. And Bay d'Espoir certainly remains the biggest plant on the island. Muskrat and Churchill obviously are bigger than Bay d'Espoir, but certainly on the island it's the largest. So Bay d'Espoir today, and so we'll jump ahead. Okay. So it's going to, even though we have Muskrat coming and Hollywood's going off, I mean, this is a really critical plant, even at its age. It's going to remain an important asset for decades. I don't see an end in sight for Bay d'Espoir for quite some time. It's in really good shape. And so, we want to invest in it appropriately. With that watershed itself, so there's the Bay d'Espoir plant, which is 604 megawatts. But on that same watershed, we do have Upper Salmon and Granite Canal. So we're over 700 megawatts for that system. So it's a really important system that we manage for the island. The system is changing, and so we do want to make sure that we take care of the plant and act appropriately to see how far into the future can it contribute, because it is on the island. We want to make sure it's in good shape. I will say this just as a quick aside. This is the third line that we added. It went into service in December of 17. We had to do some work on it last year, but this is the new line. It's 188 kilometers in length, and I can imagine that the folks who in the 60s were building those lines would have liked to have a helicopter assist them, because I think lifting them with a helicopter would be a little bit easier. About 25 towers a day were being placed with the assistance of the helicopter, which is pretty impressive. 1.5 million person hours were used to put in that line. 580 steel towers, and each tower weighs between 10 and 35 tons and has 1,000 volts. So that's just the most, I'll call it sort of touching the Bay d'Espoir system. That's the most recent upgrade that we've done. I want to take the concept of sort of reliability, and I'll bring it to Bay d'Espoir. But I just want to have a little chat, because it's going to evolve the conversation here a little bit. This is how we're going to be meeting customer energy needs into the future. So if you look at this chart, if we've got 2007, Holyrood would have been 20% of the energy that was being supplied to customers. Purchases would be things like wind, and then hydro itself was 73%. Purchases are increasing there because exploits became providing it to all of us as customers as opposed to the pulp and paper industry, so that would have been the shift. And so therefore, just as a percentage, Holyrood increased a little bit and hydro decreased. However, into the future, you can see where the system changes. So Holyrood comes offline. The hydroelectric stays quite similar. And the Lille deliveries are what, have some recapture from the Upper Churchill, but certainly the Muskrat Falls will really be how we're providing the deliveries to customers. So it'll be very much green power, if you want to call it that. And so, and I was going to say as well, other purchases could be things from over the Maritime Link, which we have already started making some purchases there when it's economic to do so. So if we have the ability to ramp back on Holyrood and we can purchase over the Maritime Link cheaper energy, we'll do the economic assessment, and if it's cheaper, then we'll certainly import energy over the Maritime Link. So we've imported, I think it's 91 gigawatt hours this year over the Maritime Link. And last year, we only imported 60 over the Maritime Link. And again, we've been taking stuff down over the Labrador Island Link as well. So I think Greg mentioned earlier, we did, in the last few years, have some pretty significant issues at Bay d'Espoir, and really related to one penstock in particular. But what we found on that penstock ended up applying across some of the other penstocks. So we want to make sure that we're managing the assets and doing the appropriate checks to make sure everything is running okay. But obviously, you're going to get caught sometimes. There's always going to be those failures that you didn't quite see coming. So we are diligent when we monitor an issue, and then but how we respond to it is really, you've got to be, so you're not going to rule out every single issue that's ever going to happen. You have to then be very ready to respond appropriately. And then you want to manage your reservoir and your water levels appropriately to make sure you are providing a good level of reliability. So every year, we're going to identify and execute the required maintenance and capital work to provide the reliable assets. The activities can be minor, just the routine PMs, to major, and they might occur, once every few years or every few decades. We complete the work during non-winter, obviously in a planned fashion. You want to make sure you're saying, okay, the load's coming off the system now. Okay, we can take this unit off. You blitz its maintenance or you blitz your capital upgrade, and then you can get that one back on, and you take the next unit off for the next transmission line. Following the work complete, we run up and synchronize, and all systems are verified. The other part that we have to manage as well, obviously, is the water. You want to make sure you're keeping enough water in your reservoirs to adjust for any dry periods. So you've always got, and we have the luxury again of these large storage reservoirs. We have that ability to hold water and decide when we're going to release it. So that's another really important part of making sure we're providing reliable service. So it hasn't been without its challenges. So in this photo, that's I guess an original construction photo. In this other one here, I think I probably took that one. It's the crack. We had 3 cracks develop at 3 different times on penstock 1 for units 1 and 2, in 2 in 2016 and 1 in 2017. And it doesn't look like a big crack for a 17-foot diameter penstock, which is huge. I don't know what the ceiling height is here. I'm going to say maybe 25 feet. But I say, yeah, 17 feet is huge. Like, I had no idea how big it was until I was, you're down and looking inside the penstock. So that crack, I mean, it's the size of a finger, but it's pretty significant when you're seeing the water come out of it. And so that, that has to be shut down. You've got to deal with it. And so we would have had one in the early 2016 or kind of late winter of 2016. Would have engaged, say, some experts to help us understand it. And it was thought at that time it was kind of an anomaly associated with the welding. And then we had a second one develop that fall. And then we got inside the penstock and did some additional inspections and maintenance and found some issues and said, okay, yep, we didn't quite get it at that time. We just sort of patched it up again. And then went back in service, worked away through the whole winter. The following year, it faulted again in essentially the same place. So we really said, okay, there's something major not going correctly here. We have to really investigate this deeply. And to decide to keep a penstock out of service for a period of time on an unplanned basis, we could take a penstock out of service as long as you want, I'm going to call it almost, on a planned basis, because you know what else you can or cannot do in the other parts of your system. On an unplanned basis, having something out of service for months puts a lot of stress on how you're dealing with all these other service requirements. So when the third one happened, I think we kicked into extra high gear, because again, anytime you have something happen, you want to get it back into service as quickly as possible. But we knew this was an extensive recurring issue that we couldn't allow to occur again. Not that the first ones we wanted to allow to occur, but it was just a very different feel in how we analyzed and looked into the root cause. And to take something that you really haven't yet understood the phenomenon required specialized equipment to be found and installed. Then you had to monitor it for a period of time. Then you had to do the engineering analysis. I think we were 3 or 4 months just getting the engineering analysis done of what do we think is going on here. And so then we ended up putting it back in service. But when you went inside, we found we had to do a lot of NDT testing. And then when we found, say, along the welds there were some issues, we had to gouge the welds out, replace the welds, and then do all the analysis on what is causing this, because you don't want to be in that same situation again in an unplanned fashion. So what we found with an expert consultant, we had national experts in penstocks come down and work with us. There were 3 components of the root cause. One was the most material contributor, but all of them together really would have been resulting in what we saw there. Localized bending stress due to original construction geometry at the weld seam. So that was not as big a contributor, but it was a contributor. So the penstock at 17 feet, it's sort of like a soup can, but a soup can that gets constructed, they're 9-foot lengths. And so you've got this piece welded to that piece along these longitudinal seams. And then you've got each of those cans then get welded circumferentially. And when we went inside, the circumference welds were fine, no issues, no concerns. The ones along the sides were the ones that were deteriorated and then resulted in this crack, in this weakened state. And so when they would have done the construction, you'd try to make, in an ideal world, you make it this perfect circle. But, I guess, standards or methods and stuff at the time, you weren't able to get this like sort of perfect circle. So instead of it being perfect, it was like a slight tiny peak at where the weld seams were. So it would have been an original component of residual stress that would have been left there and localized bending stress. That was one component of the root cause that would have resulted in the failure. The second was fatigue caused by pressure fluctuations during normal operations over the 50-year time frame. So units coming on, units coming off, a unit trip causing a surge, those kinds of things that would have occurred over time. But the most material one was fatigue caused by stresses during certain types of extended operation in the rough zone. And that was the most material aspect and contributor to the issue. And what that is down at the plant itself, the turbines all naturally have a zone with which they're not super happy. They slightly vibrate. And there's mechanical means that you can measure and monitor the unit to make sure it's okay, even if it's sitting in that rough zone for a period. You've got ways you can monitor it and check that it's okay. So you feel you've got the health of the turbine itself monitored and in good shape, you can intervene, that sort of thing. You don't ever want to be in the rough zone for very long, but I don't think it was ever understood that this phenomenon actually propagated up through the penstock. So when that was theorized, that was heavily analyzed, and that has now been determined by the experts, the engineering experts, to say that is the most significant contributor to the root cause of what went on there. And so we've made some operational changes that are significantly limiting the amount of time that we're spending in this rough zone, which causes some frustration for the actual system operators, because before they would probably be able to leave a plant somewhere, because they're trying to balance the system and all the different units. They could leave all of these units in an area that they want to do for a period of time, but we've significantly now restricted the units staying in some of these zones. So we ended up doing the repairs on unit, so penstock 1. We then went in and inspected penstock 2 and penstock 3 over 2017 and 2018 and found, let me just show you this, similar. This is inside the weld. So a lot of the weld has gone over the years. And so we would have found the same condition in penstocks 2 and 3. So we would have had to gouge out all of the welds that were suspect like this and replace them. And by changing our operating parameters, we're going to be protecting, I guess, the penstocks from experiencing those similar failures again in the future. So I think I was really proud of the work that our team had done with the experts to come up with the true root cause. And again, as far as I understand it, this phenomenon had never been determined before to exist as propagating back up the penstock. So sadly, we were the ones that kind of figured it out. But it was a really impressive then, and this is exactly what asset management should be, is you should take that learning that you learned from one situation and apply it across every certain similar assets that you have. So we've taken that learning and looked at it across the other assets. We've got to make sure our inspection program is appropriate. So, you know, the silver lining from the penstock outages in 2016 and 17 is that I think our asset management program is a lot better than what it had been. And through that period of the penstock outages, we didn't have any bulk supply issues, so we were able to continue to supply customers. Again, you were in an unplanned situation. You had significant generation out of service, which is never fun, but we were able to manage with the reserves that we carry and the other generation that we carry. We didn't have any issues with supplying customers. So I wanted just to talk really quick about reliability and how we measure the reliability of the generation facilities. Different generation facilities can use different numbers and different metrics. Like gas turbines have a metric, Holywood has a different metric, but the hydraulic units use this metric called DAFOR, and it's derated, adjusted, forced outage rate. It's similar to unavailability. You can kind of consider it like that. But it's not just the plant is unavailable. If the plant for some reason has to operate at a slightly lower rate, we sort of take a hit on our availability metric in that fashion too. So the Canadian Electricity Association is an industry association that I would imagine essentially every utility participates in Canada. And we all participate and send in a number of different reliability metrics, or all kinds of different metrics. And the CEA average in 2016 and 17 for hydro units is 6.5%. So even in the year that we had these significant issues and contributed to significant unavailability of units 1 and 2 at Bay d'Espoir, the overall was managed to be 5.5%. Again, this was, you know, tight management. We had to make sure, like, we were adjusting other outages. You know, we really, you know, took a hit that year in how we had to manage for that unplanned situation. And then in 2017, we still had that other unplanned penstock outage. The first year we had the 2. The second year we had the 1. And then last year we had no unplanned outages on penstocks. We would have had issues that crop up here and there. But we're actually now in 2018 at 0.2%. I think it might have been 0.23%, something like that. And the Bay d'Espoir Unit 1 is 0.1% and 0.6%. And I kind of broke the hearts of a few of the folks in my group a couple of months ago when we saw this number. And I was like, it might be too reliable. Because there's a balance between reliability and cost. And, you know, it's important, I think, that I'm thinking about that, and I'm talking with my employees about that, because maybe you're overinvesting here. Maybe you don't have to respond immediately to that. So it's a significant shift for hydro, because everyone knows about Dardanelle. I actually started at hydro in October of 14, and they had been through those issues in winter of 13 and winter of 14. So everyone is still kind of hurting from I guess a lack of confidence that might have developed a little bit. Let me tell you, it's the same people that work there, and the same interest and drive that want to provide really good service. So we have worked really hard to become very reliable, and this is the outcome. And then I'm like, ooh, it might be too good. And because, is it too reliable? Are we investing too much there? And there's long-term investing, which you can't see the outcome immediately, but there's also short-term investing. So if we have a unit trip off tonight, we should be thinking, okay, do I really need that unit back? It's a shift from before where you'd say, oh God, we got to go back right away. We got to get this thing back in service. You're frantic. Okay, get everything back in service, because we had just come from a place where we needed to make sure we had everything available. So our conversations are starting to shift toward what is the right level of reliability that we're providing. It's not just reliability at all costs. So a little further to that is last year, Hydro submitted to the board, the Public Utilities Board, the actual title is Board of Commissioners of Public Utilities, people often call it the pub or the Public Utilities Board. I like to refer to them as the board. And part of, I guess, some of the commitments that we've made with the board over the last few years is we have to develop what the reliability criteria and the reliability standards are for operating the system once Muskrat is in service. And it's really kind of the post system. So we developed a fairly significant assessment of what the standards should be, and provided, I guess, sent a proposal and a heavy researched file and model to the board last fall. Prior to that, though, and what we wanted to include, kind of in light of what I said just then, is what is the balance of cost and reliability. We wanted to commence talking to customers, which we hadn't done before. It was the first that Hydro had reached out and tried to ask for customers. It's not an easy conversation to have, because it's a really complicated conversation. You know, it's like we can't say, okay, how about $10 more on your bill and you'll have your outages cut in half, because it's not that linear relationship. However, we hadn't talked with customers before, so we wanted to start the conversation. So last year, as part of this future reliability report, we started an engagement. I think we called it a digital engagement with customers, and we want to continue with that to begin to commence getting some input, and then we'll have to see how can we use the input, how can we actually make sure we are delivering what the customers want. We're not over-delivering what the customers want and what the customers are willing to pay for. Or if they want something a lot more reliable, then we need to be cognizant of that too. So some of the outcomes of those results there, we actually, it was pretty interesting to do. I was on vacation, and we did we developed the questions, and there was 3 or 4 of us that were in on developing the questions. We're like, these questions make so much sense, and they'll get really good answers. And then we were coached by our communications company. You should do like a phone. We had to listen in on if they're confusing or not. And what would you call that? A test group or whatever that's called. Focus group, thank you. So we did a focus group. And the 3 or 4 of us who had, put a lot of time and heart into developing what we thought were incredibly clear questions, boy, oh boy, they were not incredibly clear questions. We had to do 2 or 3 focus groups. We couldn't talk back to them and try to explain, which is actually pretty good, because if the questions aren't clear, then we need that for information. So we did 2 or 3 iterations of the questions, and I will be honest, there was a lot of even just frustration coming out, say, with Muskrat Falls and rates and those kinds of things, and I accept that, and that's appropriate. But we wanted to start the conversation, and this is some of the information that we got back. And one of the questions was, choose one of these 3. Would you like good reliability, lower impact on cost, better reliability, moderate impact on cost, best reliability, higher impact on cost? And again, this is not going to be, okay, that's going to mean that project gets approved and that one doesn't. It's just the start of a conversation to try to help inform us better in our decision making. And you can certainly see by the few that we did get, I think we had about 2,000 respondents, which I'm not a statistician, but apparently it's actually a pretty good level of response. But we are planning on trying to go out and get some more information. But it certainly shows that people would be concerned about rates, as they should be, as I am, and I want to make sure we're investing the right amount. And this other one is the opinion of statements about investment. So on a 10-point scale, the question is, I am comfortable with our power system's current level of reliability, so I would prefer that additional investments be made cautiously. And it looks like the mean there is 7.7, where 1 is completely disagree, 10 is completely agree. So therefore, 10 would be what the amount of investment generally now and the amount of reliability I'm generally content with. I think, and on average, I wish I had this stat now, I should have had it before I came. There's 2 components to the reliability that everyone here in this room would experience that gets reported to the Public Utilities Board. There's the amount that Newfoundland Power contributes to and customers experience at the end of the day, but they can't control us, so we also can cause trouble for customers. So there's the amount that we contribute to. And I think we're probably combined in the range of 2 to 4 hours on average per customer. Some people, I'll say it, on the Northern Peninsula have a harder go of it than us townies. But then there's other people who might only, in 1 year, might only get a half an hour outage. So, but on average, that's what it is. So when you see somebody say, I'm comfortable with our current level of reliability, that might mean that, somebody doesn't want 10 hours of outage, and, you're not investing a whole lot more, and costing somebody $10 or $20 more in their bill might mean that I'm okay with the 2 to 3 hours of outage I get a year. So it's the first start of information that we started to gather, and we're going to continue to try to gather this to help inform decisions go forward. So some final thoughts. Our system has had, I think, many impressive hydroelectric assets for anybody who loves that kind of thing, and I certainly do, including Beta Spare. 50 years ago, we can see from earlier that was certainly an important addition to the province, and also was pretty impressive from an engineering perspective on the world stage. Recent issues were certainly an opportunity for us to investigate thoroughly and better inform our asset management program. I think our asset management program is good. I still want to work hard at it and make it even better. Implementation of various findings has improved our reliability significantly. And the 50-year-old plant and other hydroelectric resources has been supplying over 60% of customers' needs. And that's not going to end. We're going to need this plant for a long time. They're really, really great assets. So we're at the end, which I think somebody said, if you say, do you have any questions? People often will say no, but then you're supposed to say, what questions do you have? Because that supposedly should invite questions a little more. And a reminder, if anybody does have questions, you get a book.
Okay, we do have time for questions, so I will be walking along this side. Jackie will be on the other side. If you have a question, please raise your hand. We'll give you a mic just so everyone can hear the question.
Hi, that was a great presentation. I thank you much.
Thank you.
Your civil engineering background certainly came shining through when you were talking about the penstock problems. But I want to talk about reliability and figures to one side. I mean, the load center of our problems is right here on the northeast Avalon, St. John's. And in a perfect system, we would have generation close at hand. Mm-hmm. I get concerned when I keep hearing about Holyrood been shutting down. I get very concerned that weather like we've had over the last 2 days for a week, mm-hmm. and this big, long transmission line in the wilds of Labrador is coming down, and it's maybe coming down like dominoes. So reliability then becomes a real concern, I would think, for the Avalon. And is it going to be possible to shut Holyrood down? Now, I know if it was an AC system, you would need generation at this far end just to stabilize things. DC, I don't know anything about, so I don't know. But just from a reliable standpoint, would you not need generation close to the city?
Mm-hmm. So I will say, that's a great question. I gave Mr. Cumbie a book earlier, so he doesn't get a second one. No, it's a great question, and the review or the report that I mentioned that we started a process with the Public Utilities Board, will deal with that actually. And so what it does is it takes what the reliability standards are into the future, and we actually talk about the scenario of, say, for example, if the LIL was to fail in a catastrophic fashion, what does that mean to the major load center that you have here? And I think I am very concerned about rates, so I would want to make sure that we don't overinvest for every possibility that could occur. And because I think about the LIL, so I wasn't around, I call it, during the design of, say, Muskrat Falls and the LIL itself. But what I understand to be the case, and this will all be tested in this reliability review that we're working on with the board and all the interveners, so the consumer advocate, Newfoundland Power, the industrial customers will all have the opportunity to test the thinking and to work with us on what the appropriate level of reliability is, and should we indeed have some backup, whether that's Holyrood or something else. But the actual LIL itself is designed to ice storms, so we'll talk about ice in particular, because I'm going to call it the catastrophic failure. So the LIL has 2 levels of ice storms that it's designed for. In the most egregious locations, I think the Great Northern Peninsula, I'm looking at Terry now, my compatriot up there, in the most egregious section, so the Northern Peninsula as well as the isthmus of the Avalon, it's built to a 1 in a 500-year ice storm. And the other sections, it's to a 1 in a 150-year ice storm. My current position is that our other transmission lines as well as the distribution system, is built to a 1 in a 50-year ice storm. So if we had a 1 in a 50-year ice storm develop, if the lines are built to that level, because there's always a safety factor, but you could have catastrophic failure of a significant area of distribution. It'd be many weeks of sort of getting back in service, and the same would apply to the transmission system today. So I believe that the system has been designed and constructed to very low probability events, and so I have confidence that what's built is very robust. That's on the catastrophic failure side, and I'm afraid that if we start to invest for very low probability, I'll call that low probability event of us exceeding a 150-year ice storm, then shouldn't we therefore then be investing for the 1 in 50-year ice storms and other low probability events? So, but that's my view on one voice, and we've engaged the board to, again with all those other parties, for everyone to chime in, and the board at the end of the day to say, this is the amount of reliability that we should plan for, we should have backup, or we shouldn't have backup. So that is very much where that's going to land, I think. And I don't know how much you're interested in that sort of thing, but that should hopefully commence in earnest the fall or the winter. And Holyrood itself, I don't know if you pay much attention to it, but it was running phenomenal this past winter, quite incredible. But it also had pretty poor reliability in the previous couple of winters. So I don't see Holyrood itself as the best solution if it is indeed determined that we should have some kind of backup in the event of a catastrophic failure. So part of the reliability review that we've submitted offers, here's a whole host of options that we might be able to avail of if it was so determined that that is the right and prudent thing to do. So all that is up for evaluation and consideration. I don't know if does that scratch the itch? Does that answer?
We have another question here. Thank you.
Hey, hello. First, thank you very much for this very great talk. I never know there's so fantastic dam and there's so fantastic hydropower have serviced us for over 50 years, and that was a really huge, great work. But now I just have two very small questions.
Yep.
The first one, I really appreciate the survey could face to the customers, but I was wondering, if you let the customer the choice, good reliability and better reliability and best reliability, what's the number of it? How could you say this was a good reliability, 99% they will be available?
It's tough because it all comes down. I wish I was a statistic expert, and I'm not actually. Because it won't be an exact. I mean, this was it's an input and a sense and a feel that we believe is important to reflect in the decisions that we would make. Mm-hmm. In theory, you should go with what is good utility practice. That should be your basis. And then do you become better or worse, that kind of thing. So you use those kinds of inputs. But the good reliability or worse reliability, exactly what that number is it'll take, so one investment won't get you, would say, okay, again, if we invest $100 more million, mm-hmm. I can guarantee you that we'll have, 10% better reliability. It won't be that easy to quantify. It is a bit, qualitative versus quantitative for a period, but you really need to say, we use CEA standards. We compare ourselves to CEA. Mm-hmm. You compare yourself from a construction perspective to other utilities. You're really trying to strike that correct balance. I'm not sure if I'm answering your question.
Yeah, that sounds really good. I'm looking forward to have more surveys about these things soon.
Okay, good.
Yeah, and the second question is, I know it's really great to see we will have more clean energy and more green energy come to this province. But I was wondering have you do any research about the green, about climate change for this one, the greenhouse gas release for this hydropower, and also does this dam, as we create the biggest man-made lake, so does this one make some regional climate change for this area or for the whole island, please?
I'm not sure. I wish I knew. I don't know that, in the I'll call it the new asset coming, say Muskrat Falls. I'm going to be a recipient sort of that, and I'm only with Nalcor Hydro a few years, so I don't know that there's a ton of research on, say, greenhouse gases resulting from the flooding of some land, and I don't have any particular data myself. Whether it exists in the organization, it might, but I'm not aware of it. I'm sorry about that.
No, but this is a good question. Thank you so much.
Okay, you're welcome. Here you go.
I just have a question, wondering about if all things being, working right, and that the power supply and everything comes from Muskrat Falls is reliable and all that. Is there a possibility that power from Bay to Spear would be transmitted back through the system, like to Nova Scotia, through the link, if there was excess power to sell? Like, is that a possible revenue generator in the future?
Absolutely, yeah. And people would have probably paid some attention. And again, I pay as much attention as I can outside of my day-to-day sort of operational duties, but government is working with Hydro, and we're working with Nalcor to try to find ways to say, okay, how much can we decide to sell, and to start to get that revenue stream up and running. And I mean, there's energy sold outside the province now through Nalcor Energy Marketing, and as we get the little reliable, and then we could sort of find paths to sell the energy both through Quebec or the Maritime Link. But absolutely, that is part of the grander scheme to sell the excess energy that way. For you.
And hi.
Hello.
Thank you for the great talk. Actually, I do have a small technical question. So I
God.
work on the corrosion management, like materials corrosion management. So my question is that what is there any, like, what kind of corrosion issues you usually encounter, and how you usually manage that corrosion issue in the asset management?
So what kind of what issues?
Like materials corrosion.
Oh, some of what you would have seen, say the welds, is probably what you're thinking about when you saw the sort of the kind of spongy looking welds.
Yes.
So part of the other issue, which wouldn't have been as big a contributor, but some contributor, was the insides of the penstocks would have been originally coated with the appropriate coating system. Mm-hmm. And at some point after, we don't know when it occurred because we hadn't been inside for that real good look, the corrosion, the coating would have didn't disappear, but it kind of did not adhere anymore to the
Yes.
actual metal. And what was in the penstock was a layer of algae. So when people would scrape away the algae, say, oh, coating is there, I think we're good, but it didn't actually adhere properly to. So I don't know if that was sort of a part of your question.
Yes.
But that would be
corrosion
something.
management. Yes.
Yes, yeah. So that is something then. So as part of our rehabilitation plan that we're starting to continue to get more planning around, and to kind of rehabilitate the penstock. So we've got the welds done. Now in the next 5 to 10 years, we're going to commence the program of recoating the insides to add for that additional protection for the penstock itself.
Okay, so usually corrosion is happening inside the pipe rather than the outside.
And that's what I mean, yeah. So inside the penstock, exactly.
Okay, cool. Thank you.
Yeah, you're welcome.
First question. For years, we wish to have an engineer head of Hydro. I think you are you the second or the third since George Hopp, going back in the 60s?
I don't know, it gets a bit wonky because there was like EVPs and stuff. I don't know, because I took over for Jim Haynes, and Jim Haynes is electrical engineer, and prior to Jim it was John McIsaac, who's a mechanical engineer, and prior to that it was like an EVP structure, so that would have been Rob Henderson. So there's been, hosts of engineers, I think, there for a while.
No, but for the president.
Oh, the president, yes. And
that's a big question, because I recall, and many of us in the association are very bit disappointed with the appointments made by government, because politicians, political choices, they're sometimes good guys, but lawyers and people with business backgrounds paraded through that position. And whereas there were excellent engineers in the hierarchy that we really thought should have got the top job, mm-hmm. and brought the best knowledge of the technology into to play. Mm-hmm. So, as the top person in Hydro, are you number 2 or number 3?
Gosh, I'm going to have to update my bio and find that out. I'm really not sure from an actual title perspective. Because I think, again, from a titling, I still would have considered say a couple of people that were there before, even in the EVP role in the structure, I would have called them really the president. So it might be a bit of semantics, but I take your point because there's a point there. I know exactly what you mean. I'm not sure what that number is.
Anyway, I was going to just elaborate to the question of reliability. I worked for a system that I think probably had the least reliable system in Canada, Northwest Territories Power, but our outages were typically less than half an hour. And no, I worked on the hydro system. I was involved in the hydro system that supplied Yellowknife, and the source was the Snare River. And when I was up there, there were 3 plants, and we built a 4th plant. The worry is when you have a long outage, if that transmission line from Labrador goes down, many of it's routed through remote areas, access will be difficult, the job to rebuild will be difficult and time consuming, and this is where we think about reliability as sort of the percentage of the risk of losing power.
Right.
It's the duration the power is out that really becomes critical to the client.
Yeah, and I hope I don't minimize at all. I don't want to leave anybody with the impression that I don't take it incredibly seriously, because I do. I just want to make sure that we are appropriately building something that has whatever likelihood of probability to occur that we all agree is the right probability to guard against. Because if we do build for something and again, I'm going to say it's low probability. We'll probably, because there will be interveners that won't agree with Hydro's position on the probability. But if we say it's a very low probability, I would then argue, well, what about, again, if you think about, say, the distribution system or the other transmission lines, why not build for that probability too? So, again, to me, because of the rates that we're about to be confronted with and that we're going to have to deal with, I'm very conscious of how reliable should we indeed be. And I trust that the board and the interveners will all ask very tough questions of each other and come up with what we all, as much as we can, agree to, what the reliability criteria is, and if indeed we should have backup on the Avalon in the event of an unlikely event of a catastrophic failure.
Can we move to the next question?
Anyway, let me finish.
Okay.
I mean,
Trying to give a balance here of several people who would like to ask questions.
when we had the long outage a few years back, if the protection and control system had been differently designed, would it have been possible to limit the extent in which the system was impacted? Because this is part of the problem. The system is collapsed completely.
Right.
Restoring it becomes
Right.
a big challenge. If you can protect the system by and large by dropping some load to balance loss of generation, then the problems are a lot less critical. You may have to live for some time with rotating power
Right.
outages, but at least the system per se provide us the service that allows us to live fairly
Yes.
comfortably.
I think, I'll give you your book. I think I would like to say, and I certainly didn't in preparation kind of revisit the root cause of the things that should have contributed to, say, the significant outages that were experienced in 2014. I think there was probably a whole host of things, and I think Hydro has worked really hard to make just even operational adjustments that are not incredibly costly in reaction to that. And I think it's evidenced by this past winter on February 19th, we had a historic system peak, about 60 megawatts higher on peak than we had ever seen before. And at the time, we had 400 megawatts of reserve available. So I think we have changed a lot in the last few years without significant investment. So I think we're going to be able to, if we continue to hold those kinds of standards for ourselves, just operationally how we're doing, how we respond, I'm hoping we're going to be able to provide for what is, reasonably expected to occur without building for those extremely unlikely scenarios.
Very good. We have a couple more questions on this side.
Ms. Williams, thank you very much for your detailed outline of the root cause failure and analysis of the penstock failure there, and congratulations on your achieved L4 rates.
Thank you.
I want to ask about, in terms of reliability and the location of the load center, what level of consideration is given to energy storage on the grid, and how would Newfoundland Hydro be involved in that
So you
today
should
and in the
you should
future?
review the reliability review report we've got on. So if provincially the parties that are involved in ultimately, I'll call it sanctioning, whether we want to have some additional, I'll call energy storage as capacity, or in the event of something, that is something that would be considered as an option. So there's a whole host of options that we would consider: batteries, solar, believe it or not. We've even identified a couple locations that if we decided to invest in something else, we wanted to run through what are those viable solutions and what is the least cost solution that we would invest in. And storage, battery storage is one of the ones that we'd be considering. So you can look at the report online at the pub if you like. Book for you. I'm going to scooch around this way. All right. I'm coming around, George. How are you?
Hi, I have a question.
Oh, sorry. I thought Ms. George was
well.
next. Sorry, go ahead. And I walked around.
I think I'm next.
You're going right
Okay.
ahead. Yep.
Sorry. I had a question about the, certainly that we've used the hydraulic capacity and the reservoir storage in a certain way at Bay d'Espoir, and I guess all of the other hydroelectric facilities on the island. But of course now when we get power from Labrador and potentially new or power able to come across the Gulf, I guess we'll operate our hydroelectric facilities probably differently than we would in an isolated island system. What are some of the main things that'll change? The seasonality of the water? Will we store water longer, or will we use the facilities more for peaking operations or for base load supply of energy? How will these things change? Do you think the operations when the power from Labrador and all the interconnects are made?
So Nalcor created Nalcor Energy Marketing. Some people would probably know about that, and it was created, and it is currently selling, say, some of the Upper Churchill excess power. And contained within their group, they have hydrology engineers who work with a computer modeling system to model both Labrador, we'll call it capacity and energy, as well as Hydro's capacity and energy. Hydro works with them and has ownership of really and sign off of the work that they do. So they're essentially almost like a consulting firm doing analysis and engineering for us, and then we have appropriate people with the skills as well to kind of check their work and to make the assessments on if they're making the right decisions. And part of that relationship with them is we would have parameters that they have to honor. So for example, we plan for a 3-year dry sequence, and that's been the case. Actually, I found it interesting. I'm pretty sure that even back in the 50s, that was what the basis was that they were using, and maybe that's typical. That's one thing actually I don't know if that exists in all utilities, as a 3-year dry sequence is the standard. But that would be a parameter that we would use. So we would be considering what is all the possible energy paths or energy usages of the water, and put it into the system models to say, okay, exactly how should we be dispatching? Always protecting domestic supply if you got into a really dry sequence. And I think the dry sequence was, historically that we know about, was 1959, 1960, 1961-ish. And if anybody's of that vintage, there was apparently significant forest fires in Central around that time as well. So that is the dry period that we use as the model for, okay, we got to make sure that we always keep enough in storage so that if we have to, we'll be able to supply domestically. So a lot of the existing parameters for how we manage the system will just expand to include, there's just more, looks like we got new ponds basically to pull on. and will always be owning the output and the decision-making associated with that. So that is, oh yeah, and I will say further, a lot of that is the scheduling protocols and those sorts of things are under development right now. So we do still have a little bit of time to finalize that, but that's still under I'll call it finalization and fine-tuning.
My question was similar with regards to storage and
Yeah.
whether or not you've taken into account any climate change that might affect the water levels,
Yeah.
snowpack, reservoir levels.
Yeah, I'll give George a book too. George was my first manager in St. John's Region back a few years back. George looks like he's been spending time down south. I recently asked, so I haven't done a deep dive and research myself on the climate change impact and how it's going to impact. I should move down so people aren't craning their necks too much, sorry. I haven't done a ton of research, but I recently inquired. We've got a climate change committee. It's a combined of both Hydro and Nalcor people. And I've recently asked for a bit of an update on what does that mean. And as I understand it, the preliminary feedback that I have is that we'll get the same amount of water, it just might come at different times. So we're just going to have to adjust and be ready for, so that's, I'll call what the science is currently saying. So you're going to get the extremes, which I think we all hear that in the media ourselves. When we hear about climate change, you're going to get extremes. So when it comes to actual fuel, which is water, I think we've got to be ready for what the extremes are. So if I think about Hurricane Matthew, which hit Bay d'Espoir in the same year, actually, so that was like my year from hell. It was 2016. And we would have had the penstock that had the out of service, and then at that Thanksgiving weekend, we had Hurricane Matthew that was coming. And so we need to be more ready for those kinds of situations and to make sure, so operationally we're ready. But at this point, I don't have any science to say that we'll be in worse shape, that we should get the same quantity through the run of a year. So we'll probably want to be a bit more conservative in our development of security with the dry year sequence concepts.
Okay, thank you for those questions, Jennifer, and thank you for this very informative and interesting presentation. I must say, I certainly learned a lot about the electricity system in Bay d'Espoir, and also congratulations on your recent position as president and your exceptional leadership that has made all of these successes possible. So on behalf of the Faculty of Engineering and Applied Science, I'd like to just give a small token of our appreciation, and let's thank Jennifer again for this very interesting talk.
Thank you very much. Good.
Okay, so at this point, I'd like to invite Jeff up to say a few words on behalf of Paganel.
Thank you very much, Greg. And just a few words. It's very important for Paganel to be part of this. And, we're concerned about what people of the province know about engineering and geoscience both, because we both are regulators of engineers and geoscientists, but in this forum, engineers primarily, and that important that we participate these things and get the messages out about what engineering does contribute to the province, and it's very important for us to do that, and we really thank Greg and the engineering faculty for allowing us to partner in this activity. A little bit about Paganel. I see many in the audience who are license holders with Paganel or life members or a number of categories. But, for the benefit of those that are not, we are basically a licensing body. We were given the responsibility by the people of the province to administer an act, much the same as the Medical Licensing Board, the College of Physicians and Surgeons, now the College of Nurses. We play a similar role in terms of licensing people and calling to people to account when they don't perform to the right standards. And so that's really about what we are about. We administer an act on behalf of the people of the province in the interest of the people of the province. Just a little comment about the Bay d'Espoir project itself. I had the privilege of starting my career around 1970. I'll tell you how old I am now. When they say 50 years, well, I was there. I was as I know
George was. I was a co-op student in 1970 at the Power Commission, and that was a very exciting place to be at that time. And as a co-op student, you were amazed by what was around you, but especially the leadership of people like some names that I've heard today, George Hobbs, Wally Reed, Leo Cole. They were the leaders of those people, and they put in place a really profound facility that has served the people of the province so well for these 50 years. And you know, it's like an old car that runs forever, or a house that you don't have to maintain. You really don't notice it. It provides value for many, many years, and it's only when it breaks down do you know that it's the value that you've lost. And I guess that's the same is true of our electric system and as a whole. So when I look at this is what I see is the tremendous value that people put in place in those times, and how it served us both in terms of what they put in place and the people at Nalcor who operated all those years. Just a comment to thank Jennifer. I've worked for Jennifer for many years, and I was really thrilled to see her the new president of Hydro. I know the dynamism and the concern for customers and people and the leadership that she will provide at Hydro, and I look forward to that very much. So thank you very much.